Okay, so this is in addition to chapter 11. We've already talked about the volume of prisms and pyramids. Today we're going to cover the surface area. Now this one's going to have a lot of formulas. Tomorrow when we cover cones and cylinders, it's a lot easier. But this one, because there's so many different types of prisms and pyramids, this one's a little bit more challenging. So first thing we're going to talk about is lateral area and surface area. So the lateral area is the sum of the areas of the lateral faces. So basically all the faces on the sides of either your pyramids or your prisms. Surface area or total area, and you're going to see these names interchanged, is going to be the sum of all the areas of its faces. So basically it's going to be the lateral area, the LA, plus the area of the base. And when it's a prism, we're going to have two bases, the top and the bottom. But when it's a pyramid, there's only one base and then all the lateral faces. All right, so again, the lateral area is the sum of all the lateral faces. So basically all the faces that are on the side. The surface area is the total of all the areas. The bases, the top and the bottom if it's a prism, and then the lateral faces. If it's a pyramid, there's only one base, and then it'll have however many lateral faces it needs, however many triangles, depending on the base shape. Okay, so now here is the prisms. We have a picture of a rectangular prism, a triangular prism, and a hexagonal prism. To find the lateral area, the area of all of the faces, you are going to find the perimeter of the base times the height of the prism. So in the case of the rectangular prism, you would find the perimeter of the base and then multiply it by the height of the prism. And that will give you the area of all the faces. And again, remember, you could find the area of each one of those four rectangles or parallelograms and add them all up, and that would give you your lateral area. So this is everything except the base. So this is all areas, not including the area of the base. Then for the total area or surface area, and these two words are going to be used interchangeably, you would take the lateral area plus the two bases. So you'd find the area of the top and the bottom and add it to the lateral area. Or you can also say 2 times the base area plus pH. And remember, pH is up here. It's the lateral area. Total area is the area of every face. So it's the base areas, top and bottom, plus all the lateral faces and the area of all those. That's what surface area is. Now, when you're doing this one, it really doesn't matter because all of your bases are rectangles, which one you decide is the top and the bottom. However, in the triangular prism, it matters. The base of this one is the triangle. So you have 2 triangle faces and then 3 rectangle or 3 parallelogram faces that you would find the areas of to get total surface area. In the case of the hexagonal prism, we have 2 hexagons, and then we have the 6 parallelograms or 6 rectangles around the sides. And you would find the areas of all of those. But again, the shorter way is to find the area of the base. And for the hexagon, we're going to use that polygon formula that we learned in 11.3, and it was 1/2 ANS, where A was the apothem, N was the number of sides, and S was the side length. So we would use that to find the area of the hexagon, and then to find the lateral faces, just find the perimeter of the hexagon and multiply it how tall the prism is. That's the shorter way instead of finding the area of each rectangle. We will. We're going to do some examples coming up. Next is the formula or the methods to find the lateral area of a regular pyramid with n lateral faces. So method 1 would be find the area of one lateral face and multiply it by the number of triangles you have. Method 2 would be to use 1/2 the perimeter times the slant height. The slant height is indicated by a lowercase l. So for example, if I were to draw a pyramid here, the slant height is going to be down the sides here. And this would actually have 4 slant heights. This is the slant height, and it's indicated by a lowercase letter L. So if you wanted to use method 1, you would find the area of one of these triangles, and notice it's a square base, and then you would multiply it by 4. That's method 1. So you find the area of one triangle, which is 1/2 BH, and in the case of the square or the rectangular pyramid, if it's a square pyramid, then you times it by 4. And this is for regular pyramids. So the base here would have to be a square. So once you do that, find the area of the triangle, multiply it by 4, and then get to the total surface area, find the area of the square, and then add it to that. Method 2 is to find the perimeter of your base, and then multiply that by 1/2, and also multiply it by the slant height. So 1/2 perimeter times slant height will also give you the area of all the triangles on the top. Next slide. So we just saw lateral area for pyramids on the previous slide. This is total area. So again, remember total area or surface area is you're going to find the lateral area and add it to the base area. And to find the lateral area, you're either going to find the triangle, multiply it by however many number of triangles you have, and then add it to the base. And again, the base area, or the perimeter, the lateral area, LA, can either be found by doing this or doing 1/2 the perimeter times slant height. Either way. And we're going to see some of these examples. So here is our first example. Now, the first box, we're looking to find the perimeter of the base. The second box here, this B, it wants the area of the base. Then LA is the lateral faces, and I'm going to change this V to total area or surface area. So the last box I'm actually going to fill in with surface area. We already covered volume of a prism. Okay, and in this case, this would be a rectangular prism, and you would just do length times width times height. But let's go ahead. Now, when it is a rectangular prism, technically you can decide what's the top and the bottom, or the two bases. Maybe just to have consistency, let's name it. It'll change your perimeter and your total base area if I decide that this is the top and down here is the bottom, that the two bases are there. But if somebody else decided, you know what, maybe it's sitting on its side, and maybe this is the base over here and over here. I'm going to do it with what you logically would think as top and bottom. So I'm going to find the area of this base and the perimeter of this base, okay, which is the same. The top and the bottom are the same, the two bases. So the perimeter of the bottom could be found by 4 plus 4 plus 2 plus 2. So I would add those up, or you could also do 4 plus 2 times 2, and the perimeter is going to be 12. Does that make sense? So you're finding the perimeter of the bottom shape. To find the area of the bottom, which is a rectangle, you're going to do 4 times 2. So the area would be 8. To find the lateral area, we're going to do perimeter times height. This 6 is our height. I guess I should do another color here. So the height is the 6. The perimeter we already calculated up here, and it's 12. So for the perimeter box, or for the lateral area box, I'm going to do 12 times 6, which is the height, and I get 72. Then for total surface area, I'm going to do 2 times the base area. Let me do this in yellow on the blue writing, on the blue background. 2 times the base area. So for the surface area, or TA, the total area, 2 times the base area plus the lateral area, or the pH. Okay, so my lateral area was 72. And my base was 12, so was 8, so 2 times 8 is 16, 16 plus 72, and I get 88. So my total area is going to be 88. And these are all centimeters squared except for the perimeter. The perimeter will only be centimeters. The base area is centimeters squared. The 72 is centimeters squared, and so is the 88. So all areas, lateral area, total area, area of the base, they're all centimeters squared. The only one that is just plain centimeters is the perimeter. Okay, now we have a triangular prism. Again, the shapes on the top and the bottom, it's kind of hard to see here, are triangles. I need to find the perimeter of my base shape. Notice up here, I've got a 4, so I can actually fill in the numbers because the top and the bottom, they're going to be the same shape. They're going to be congruent. So I can get the numbers and fill them all in from, if it's labeled on the bottom, and whatever is missing, I can get from the top. So the perimeter of the base shape is going to be 3 plus 4 plus 4, and I get 11, and these are, again, centimeters. Perimeter is just whatever the units are. Next, I need to find the area of my base shape. This in the top triangle, I know it's kind of hard to see, but I do have the height of the triangle. The height of the triangle is right here, it's 2.8. So the base shape is a triangle, so the formula I'm going to do for that is 1/2 BH, where my base is 4 and my height is 2.8. And I'm going to multiply that by 1/2. So I could simplify here, change this to a 2, and then 2.8 times 2 is 5.6 centimeters squared. And that is the area of one of the triangles. Then for the lateral face, Remember, that is perimeter times height. I have the height of my prism right here. It is 6. I already calculated the perimeter in the very first box. So I'm going to do 11 times 6. And my lateral areas, the areas of all 3 of those rectangles, is going to be 66 centimeters squared. And again, I'm going to change this V, and I'm going to put it as surface area, or total area. So I'm going to do 2 times the base area plus my lateral area that I calculated in the box above. So I already did the base area, but I have 2 triangles. So 2 times 5.6 plus the lateral area, which was 66. And 2 times 5.6 is 11.2 plus 66, giving me a total surface area of 77.2 centimeters squared. Okay, next slide. All right, example 3. Okay, a cube has a volume of 8 centimeters, of 8 cubic centimeters. So a cube has a volume of 8 cubic centimeters, and it wants us to complete each statement. Now, we already covered volume, so I need to find the length of each edge of the cube. So remember, volume is length times width times height, but in the case of a cube, we know all the sides are the same, so we could just say it's side to the third power. So if it's 8 equals side to the third power, I would cube root it and find out that my side length or my edge is 2. So that's what I'm going to be using when I do the total area of this cube. Again, remember the formula for total area is 2 times the base area plus the lateral area or the perimeter times PL. Okay, so, or I could do LA. So here, I'm going to find the area of the base. So if we know that in our cube, let's get a visual here. Let's draw a cube. And we know each one of the sides are 2. So I know the area of my base is 2 times 2. So my base area is 4. And then the perimeter of the base is going to be 2 plus 2 plus 2 plus 2. So the perimeter is 8. So what I'm going to do here is 2 times my base area, 2 times 4, plus my perimeter, which was 8, and my height, actually this is height, pH, it's going to be 2. So then 8 plus 16, and my total area is 24 centimeters squared. Another way that you might see the surface area of a cube is 6 times side squared. So if you know the side length, just square it and times it by 6, because all 6 faces are the same. Next slide. We have a regular square pyramid. So now we're going to see the pyramids. That has a base edge of 6 centimeters and a lateral edge of 5 centimeters. So let me go ahead and draw a square pyramid here. Okay, so it says a regular square pyramid has a base edge of 6. So that's telling me that all of these sides on the base are going to be 6s. And then it says that it has a lateral edge of 5. So this will be 5. This will be a 5. A 5. And there's another one back there, 5. So all of the lateral edges are going to be 5. It wants us to find the slant height, the length of the slant height. is going to go down the side here. So that's going to be my slant height. So what I can do here is I can pull this triangle out, or this whole face of it. This is 5, this is 5, this is 6, and then I'm going to draw the slant height down here. Notice here, when it bisects it, it's 3. Anybody recognize the Pythagorean triple here?
4.
So it's going to be 4. So my slant Pythagorean triple. All right, so if you don't remember the Pythagorean triples, what we're going to do here is instead, let's do Pythagorean theorem. So I have a right triangle here. So I'm going to do x squared plus 3 squared equals 5 squared. A 3, 4, 5 is a Pythagorean triple. So I'm going to do 9, 25, and then I'm going to move the 9 over. X squared equals 16, square root it, and my slant height is 4. In the lateral area, I am going to find the area of one of my triangles, which is 1/2 base times height. And there's 4 of them because it's a square pyramid. I have the base, it's 6, and I have the height. I just found it, so it's going to be 6 times 4 divided by 2, or times 1/2. So my base is 6, my height is 4. I'm going to do that whole formula and then times it by the 4 triangles that I have. So this will give me 12 for just one, 6 times 4 times 12, and I get 48 centimeters for the lateral area, centimeters squared. The length of the slant height is just 4 centimeters. For the base area, that's easy. It's a square. It's 6 times 6, and it's 36 centimeters squared. So now to find the total area, I'm going to take my base area, which was 36, add the lateral area, which is 48, and I get 84 centimeters squared. Now, remember the altitude is going to be the height of the pyramid. So the height is going to be inside here, right at the center, from the tippy top of the vertex. I need to find the altitude. So again, I'm going to make a special right triangle. So I'm going to use the slant height, and I'm going to also use half of the distance here. So I have a special right triangle here. I'm using the slant height, which is 4. I'm using half of the base length, which is 3. And then I'm going to look for the altitude. So again, I'm going to do Pythagorean theorem. This time the hypotenuse is 4. It's not one of the legs. So I have to do Pythagorean theorem. It's not going to be a triple. And 3 squared, 4 squared, 9, 16, subtract 9, and I get x squared equals 7. So my altitude is the square root of 7. We're really not covering volume here, but we did that before. Remember, it was the formula, and you'll need to know it for the test, is the 1/3 BH. So really what we could do here is our base area was 36 times our height, which was radical 7. You could simplify here, so the volume would be 12 square root 7 centimeters cubed. Example 5. We have a regular triangular pyramid. So let me go ahead and try and draw a regular pyramid here. And let's make some. Okay, so let's go ahead and label our given information. We have a slant height of 9. So that's right here. Or no, let's not do that one. It's going to be over here. I'll draw it down to here. Here's our slant height. It's 9. It says we have a base perimeter of 12. So if it's a regular triangle, we know it's equilateral. So if I do 12 divided by 3, I know each one of my sides is going to be 4. Down here, the red. Let me make them in red. So each one of the sides of my base are going to be 4. So to find the lateral area, you remember it's 1/2 perimeter times slant height. So here I'm going to do, and they've given me everything I need. It's not like I have to do a special right triangle to get this part. So my perimeter was already 12, so 1/2 times 12 times 9, my slant height. I could simplify this, make this a 6, and 6 times 9 is 54 centimeters squared. My base is, my base area is an equilateral triangle. I don't have the height. I need to do a special right triangle here. So I'm going to take my red triangle base, and let me redraw it down here. And for the base area, I need to find the height of my equilateral triangle. So if I know I have an equilateral triangle, I know that each one of the angles in it are 60 degrees. So as soon as I draw in my altitude, I now make a special right triangle. And I know that this angle up here now is going to be 30 degrees. So I know that opposite 30 is A, opposite 60 is A root 3, and then this is my 2A. So if this is 2A, then I know A is 2, and I know my A root 3 is 2 root 3. So to find the base area, I'm going to do 1/2 base times height. So 1/2, 4 times 2 square root 3. I could simplify here, make this a 2. So my total area is going to be 4 square root 3 for the base area, the total base area. So 4 square root 3. And then to find total area or surface area, it's the area of the base plus the lateral area. And because I've calculated each one separately, I can say that my base area is 4 square root 3 plus my lateral area, which was 54. Because the 54 doesn't have a radical, that's my answer, and centimeters squared.